So my name is Emmanuel Bernard. I'm architect in the middleware side for more or less everything data inside JBoss. So I'm working with Tristan on JBoss Data Grid, but also hold the Hibernate integration inside EAP and other products, and many other data-related projects. Tristan?
So yes, I'm the lead of the Infinispan project, and so we do all the in-memory stuff, and sometimes we use some of the things that Emmanuel does, and sometimes they use some of the things we do. So that's a great example of
so we got great fun of circular dependencies with this project. Cool. So we'll try to make it more abstract than those specific projects, unless you guys start having very specific questions. But start to think about those projects or the product associated to them. And if you have any questions on those or remarks, just start shouting those questions to us, okay? We'll start talking and exchanging with Tristan, but we've been doing that for quite a while. So I guess we're going to continue the conversation we started a long time ago. But you guys, stop it and try and ask questions or comments and whatnot, okay? I'll try with some kind of a postulate. First of all, who was somewhat interested with the NoSQL idea of that conference? What did you guys come for? I don't know, the only place available or what?
They were offered free beers.
Free beers? Nah, that wasn't true. Okay, so I don't know if you guys already, who uses some kind of NoSQL already in their applications? Okay, what do you use? Elasticsearch. Anything else?
Using ModeShape.
ModeShape? Okay, cool. Well, don't send me hard questions. I'll be hard pressed. Okay, I often also hear about Mongodb, for example, or Neo4j. That's a very popular ones. What's interesting is maybe you don't use them yet, the NoSQL approach, but you're thinking about them. I've got a whole presentation about what it means to have NoSQL inside your system to store your data and what it means to have an object mapper to use them from Java. That's tomorrow. So it's just a super shortcut version of that. But when you start using NoSQL, you will start embracing what is called a Polyglot Persistence world, where the same data in an abstract way will be stored in physically different containers of data, depending on the use case you have. So let's say you have a relational database that stores your canonical data. You use Elasticsearch, which means you're taking that data and creating what is called an inverted index so that you can query that data in a very efficient way. For ModeShape, it's probably your primary data store for what you're storing, but maybe it's not. Maybe you've got the data and then a subset of that data you want to store it in a distributed hierarchical database and be able to do some kind of interesting query on top of that. So you will have to decide or accept the fact that your data will be stored in, the same data will be stored into those different ones and have to maintain those in somewhat of a consistent shape. So that creates a lot of interesting questions. My take on that is it seems to me that the middleware is getting, I guess, more important in that because that will be the piece of data, whether it be your application directly or via some kind of framework. But we will push the information in a duplicated fashion to each of the backends. So let's say I'm storing the data to a relational database and I want it to be searchable via Elasticsearch. I will also send the Elasticsearch indexing request so that the data in Elasticsearch and in the relational database will be the same. That's an example. That's something we do we will do soon in a Hibernate search, for example. I don't know if you have any comment on that. But
the thing is that you're now choosing where to put the data depending on the shape of your data. In the past, we were always having to choose. Someone had already chosen the box where the data had to go, and whatever data it was, and no matter how fast I needed to access the data, that didn't matter. I've got the box. Developers, that's what you got to use. Someone else made the decision. And now instead, it's backwards. I choose, but then this choice brings so many different interesting new problems. So my data is in the shape I want, in the box I want, but now I have lots of boxes.
Right. Let me challenge that a little bit. Who has control of which database or data store it can store the data on? Or is it forced upon you to use, I don't know, Oracle DB or some other ones? So who is somewhat forced to use a specific? Not too many. OK, you got some kind of flexibility. I think for those people, you can kind of cheat a bit your I guess, production guys by saying, oh, don't worry, we store the data in this relational, your sanction store, but we will also store it in a different fashion in those additional stores, but that's OK. In case they crash, we still have the relational database. So that's an interesting way to get some of those interesting tools with an interesting characteristic into your IT. Something that is not written here that is also interesting in NoSQL is there are several reasons why you will choose one product versus another. First of all, there is the actual functional capability. So Elasticsearch, Solar, or Lucene are inverted indexes that lets you do full text search, but it also deduplication of data and lots of interesting things like that. Neo4j is a graph database that lets you create nodes with connection between one another, and then I guess query that to extract some kind of pattern or do a quick search on things. Infinispan has many facets, but one of it is like being I guess a super cache of sort, where you say, hey, I want to retrieve that information extremely fast. So that's the functional aspect of it, and the non-functional aspect of it is, what is the topology I want? Should I want one big machine or small machines, master and slave, passive, active, masters? All of that, depending on your use case and requirement, will direct you to one project and another. And I do recommend you to watch, I think it's called NoSQL is Dead. It's on InfoQ. It's a nice presentation by the guy doing Basho. He explains that in an interesting way, where he says, oh, all those NoSQL families, it's kind of passé. You need to rethink a bit how you see stuff. Any comment or remark, or so far so good? OK. So let me present you some of the projects that are related to data, give you like a quick extract, and then if you have questions or remarks, let's go and shoot them and discuss. Hibernate OGM is the NoSQL equivalent of the Hibernate ORM that you probably know. Who is using Hibernate, the object relational mapper? OK, good. Yes, still winning. So OGM is an experiment saying, OK, what if we take the Hibernate engine, like 90% of the code, but then make it store the data not in the relational database, but in a NoSQL database? And we did start it with Infinispan because some of the Infinispan users were like, OK, I like the distribution, the scalability of the system, but the whole key value store is a bit of a too low-level API for me, and they already had this domain model that they wanted to persist somehow to the grid. And they considered writing their own stuff and then realized, actually, the JPA API is pretty good. And then they realized, should I write my own JPA engine for Infinispan, or should we try to use Hibernate and I guess trick it into storing data into Infinispan? And that's what we did. And then we realized that the kind of stickiness between this new Hibernate OGM project and Infinispan was very low, and we started to abstract that to store the data not only in Infinispan, but also Mongodb, Neo4j, and so on and so on. So that's what we have. You still use the JPA API, but we store the data in a NoSQL. So I mentioned Neo4j, Hcache, Infinispan, Mongodb. That's the one we consider supported and stable. And the one that we're working on at the moment is Cassandra and CouchDB. So we're fairly confident that we kind of nailed the CRUD, the create, read, update, and delete of things. The challenge we're working on and still trying to improve is the query side of things. We've got two approaches. One is to say, well, let's embrace the native query language of each of those systems. Let's say Neo4j has a Cypher query language that lets you express this kind of, which is the friend of my friend who likes, I don't know, potatoes. I guess that would be a lot of people, but you got the idea. So you could express this native query, but then we would map it back into an actual object, as in a JPA object. And then you can update the object, navigate from one object to the associated object. Maybe it's a many-to-one, maybe it's a one-to-many and a collection, and so on and so on. So you create the native query, and then we expose those managed objects. So that's one approach which works and lets you do any query, basically. And the other approach we're really trying to explore, which is hard, is let's take JPQL, the query language that is expressing constraints on the object and let's say that the object attributes and the associated objects and so on, and convert those kind of constraints into the native query language of each of those systems. MongoDB, Neo4j is the one we are.
That means I can replace my data store at any point in time.
So I don't sell it that way because that's a bit of a, I mean, that's a nice goal, but it's a bit of a dream. It's like, if I was a salesman, I would sell it to you like that. But in practice, what it really gives is, the advantage is A, you know well the JPA API, so that's already good. B, yes, you can start working on your project as long as you're storing domain model and start with one of the data stores here and realize, you know what, it's not the one I need. Maybe I don't know, the query system is not as good as I wanted, and so on and so on. And you will be able to switch before you go to production into maybe another one, okay? Once you're in production and have, let's say, a few millions of records, then converting that from one to another is a bit of a challenge, and that's the harder challenge where OGM is not really trying to actively help you in this area, at least not yet. And the other thing is, but yeah, you will have to come to my presentation tomorrow. But there is because we have this JPA abstraction, there is a lot of things we can guess and do better for you with Hibernate OGM. Yes?
So what protocol did y'all use to connect to it using OGM? Is it the hot rod protocol, or do you choose the protocol, or is it?
No, at the moment we use the actual library mode, which means it's the Java,
embedded.
Right? It's embedded. And it works quite well, and the massive advantage is that we can participate in a transaction. So the transaction that Hibernate OGM might participate in would actually be a transaction for the backend, right? Other backends like Mongo don't have transactions, so we do something a bit different. We want to go through the hot rod approach. They don't support transaction, and there is, I forgot, but there is another feature that grouping is another feature we would really love to get before we really go and embrace this. Yeah, it's like I'm not doing it, right?
We're an open source project, just
contribute. Yeah, awesome. Yeah, so I don't know, if you're actively interested, yeah, come to talk to Tristan, ask him to do those two features, and then. But it's not too hard. So we got this notion of data store providers, and most of the code will be shared between the embedded mode and the hot rod mode, except maybe a few things. So there, I mean, once we really commit to go there, it shouldn't be too hard. And if you're really interested, just give it a try and come back with us with prototype, and then we'll, I guess, be compelled to work on it actively. By the way, that's the same for Neo4j. At the moment, we use the embedded mode. We're planning to also work on the Neo4j remote server a bit later. We really had to focus on not too many things in parallel, basically. Let's talk quickly about Hibernate Search. Who knows about Hibernate Search, the full text Okay, not enough people. So Hibernate Search is using Lucene, so it's a bit in the functional category of Elasticsearch or Solr, except it's not a box in the sense of it's a product you install on top of Tomcat or even as a black box. It's a library that you use and embed inside your application. But what we do is every time, there is several modes, but let's say the popular one is every time Hibernate, the object relational mapper, change information like create an entity, update an entity, delete an entity, it generates an event. And that event is actually listened to by Hibernate Search, and we keep the Lucene index transparently in synchronization between the database and your application, which is really a massive problem when you have basically an inverted index of sort. You need to maintain what the canonical source changes are happening and also have the inverted index in a synchronized mode. So we do that, and we do that in an efficient way, just like we try to use the best way the Lucene API is supposed to be used, so you don't have to think about that. You really have to think about the kind of query you want to do all of that. And we have a nice, I would say as powerful, but also more compact and more readable query API that is built on top of Lucene. That is what we call the query DSL, which is using a Fluent API, quite interesting. What can I do with a full-text search engine? Well, the classic thing is you can search words just like you do in Google, and it returns the most interesting results on top, and then the less interesting one at the bottom. Okay? But you can also do other things like approximation. Hey, the guy had a typo, put, I don't know, Hibernate Search forgot the A or something. We can still find it. You can custom your query to also return approximated results. Of course, their score will be lower, so they will be a bit lower in the result list, but that's exactly what you want. You can go to cool things like phonetic approximation. So somebody types search, I don't know, CH, ARCH, I don't know, whatever. We'll be able to kind of find it as well. And I helped a customer recently on deduplicating records. So they were taking a record and say, is there something that really suspiciously looks like this other one? And they used the inverted index and what they call the terms to actually guess if two records are actually looking very much alike. And then they applied some kind of rule that is proprietary to their business to really decide yes and no. And then either they update the existing record or they create a new one, depending on the decision. So that's quite interesting.
Also, having a local index allows you to do queries nearly locally without relying on the remote database, which might be a shared resource and might...
That's true. They
might not, again, when something is administered by someone else, they might not allow you to do massive queries with huge cardinality and things like that. But with something like that, you can get very fast results without affecting the database.
Yeah. Who uses the full text capability of their relational database? Nobody? Well, it's doable. There is like a basic features that lets you do that, but very quickly you lose some of the flexibility to do the advanced stuff that I was talking about. Custom approximation, deduplication, phonetic approximation, all of the things will not be very flexible here. Let me finish something. The second advantage is, as Tristan was saying, is instead of actually running the query on this single big box, which is your relational database that might already be quite busy, you literally have the indexes in each of the middleware nodes that needs to do the query, and you distribute the load basically across the different nodes, and each can execute the query and return the result without affecting the CPU of the database. Yes, you had a question?
I was just wondering, does it go into faceting, or is that something?
Yes, we also do faceting. We have an API that lets you decide the kind of faceting you want, like I want the 0 result on, as well. I don't know, I want a range-based faceting and so on. And we do also...
more like this?
Yeah, we do more like this, which is, here is a result, and I want the result that looked like this one. A bit like what I was describing for the customer. They used a slightly different deduplication approach, but they could have used more like this in an abstract way. And the other one which we do is the geolocation. So you say, hey, give me the result that match some kind of full text query, but also within the range of 5 miles away from me, for example. So we do that with two approaches. One is a simple latitude and longitude comparison to just be in a box. The other one is use a flattening algorithm called quad-tree that says that take Earth and split it into 4 boxes, and each box is split into 4 boxes up to, I think, 16 times, and you get a range up to, I don't know, 200 meters or something. So you really can drill down to something very specific or something very wide, and it works very nicely if you have a lot of objects, like more than 100K objects you need to filter away. It would be more efficient than the latitude and longitude thing I was describing. Clustering, we've got different approach. The one that is classically used is the JMS. So Lucene works very nicely if you got one master that actually do all the indexing, because it can go very fast, keep the lock, and then pound the underlying, I don't know, hard drive. And so every slave, so every part of your application that says, oh, there is a change in the database, will just send a JMS message to the master, and the master will say, okay, that means I need to index that information. We'll do the index, and then the second step is to take the index that the master has and copy it into the slaves. So you got different strategies. One is it's kind of an rsync-like copy that we do every n minutes. The other one that some customers use is to say, I've got an NFS file, and I index, there is one master that indexes the information on that NFS file, and all the slaves can read the same NFS file. As long as they are read-only, it works quite nicely. And another one that some customers use is InfiniSpan. So instead of storing the index on a file system, which is a classical approach, we store the index inside InfiniSpan, which distributes it into different chunks on the grid and gives a quasi-instant visibility of the changes and very fast access, obviously. So Hibernate Search is part of JBoss EAP for free. Just go and grab it. And what's funny is that we don't have that many bugs. We know we have a lot of people using it, but not that many bugs. So at some point, the product manager was like, hey, we never hear about these projects. Like, well, yes. And then when we looked into the bug tracking system, we realized that people use it because we saw it in the stack traces, but not actively open bugs because I guess there's no bug. I don't know. Oh, there you go.
OK, well, InfiniSpan, we've spoken about it a bit up to now. So it's more than an in-memory key value store, it's a key entity store, and that's the connection with Hibernate Search we'll look at, where I can obviously extract information just by knowing its key, but I can also, thanks to Hibernate Search, go and find it by its value, by bits of its value. I can index parts of it. So that's
find a user by email or first name.
Yes, or and with all the interesting non-exact searches that Hibernate Search allows you to do. And
it is quite unique in this category of key value or even distributed data stores, like the full text search capability that Hibernate Search brings is very unique. So interesting combination.
Yes, and I think it's the difference between being exact and approximate, and you might want to use both approaches.
Right.
So InfiniSpan does that, and it mixes it with a bunch of different ways of doing it. So local clustered, it has transactions, which not many NoSQL stores have. You can run it embedded. You can have it remote using Hot Rod, which is a special intelligent protocol, or you can use REST or WebSockets.
Special intelligence?
It's got special intelligence, superpowers.
Nice.
It knows where the data is and goes directly to the node that contains the data without having to do hops across the nodes.
That's as opposed to, for example, the Memcached protocol, which will just reach one of the server randomly, and then the server you access might do a hop to reach the data.
Yeah, because the server that you talk to might not be the owner of the data. And then we do fun things because we got all the data there and distribute it across the nodes, and we can run code against it. And so run the code local to the data. And so all the various MapReduce, distributed execution, fancy things like that. And obviously the query stuff that I mentioned earlier. So
well, so on the query, actually, let's zoom a bit. So it uses Hibernate Search underneath. So Hibernate Search, instead of listening to the Hibernate Object Relational Mapper events, it listens to the InfiniSpan events and store the index in the grid, and that's how we can do the query. And on top of that, we created kind of a JPQL to Hibernate Search query transformator, so that you can write your JPQL query on the entities that are stored in your key value store in InfiniSpan, and literally express those simple queries and get the information out of that.
And well, we're adding new things. So it's a fast-moving project. And actually, one thing that I've seen InfiniSpan used as was, again, as a way to get information faster. So your primary data is somewhere else, but querying that data is a pain. So you bring it into your in-memory data grid, and then you can run queries there in a much faster, more flexible way. Because some of these other NoSQL stores sometimes don't have interesting querying ability, and that's what differentiates us from the others. For example, I remember in this particular example, there was a Cassandra database, and Cassandra has some indexing abilities, but you can't really do complex queries. It's all by key, but by column and so on. So InfiniSpan, in that case, allows you to enrich the capabilities of an existing data store.
And we're back to the duplication thing, where you say, hey, I'm just putting InfiniSpan alongside or in front of my Cassandra store, which will be my reference of record. But then for this query, maybe on the most recent data, I'll be able to be more performant all in memory. And of course, yes?
Question one, are your recommendations about using InfiniSpan actually as a persistent key entity store via the cache store APIs?
So the cache store API, the recommendation there depends on what kind of guarantees you want. And so it all depends on whether you want a shared cache store or an unshared cache store. So unshared means that each node only saves to its local cache store the data that is dedicated for that node. Shared means that all the nodes put it in a huge big bucket. So an example of a shared cache store is a JDBC cache store or the JPA cache store.
Or Cassandra.
Sorry?
Or Cassandra.
Yeah, the Cassandra cache store is a bit of an
okay.
holiday.
Forget what I said.
It needs love. So it all depends on how you want that data outside of InfiniSpan, if you do need it outside of InfiniSpan. So my recommendation, if you don't need to access that data using the tools of your persistent store, then unshared is best. And at that point, I would recommend the LevelDB store, which is the most performant one at the moment.
Carry on.
Anything else would be the JDBC cache store is the one that gives you the most guarantees of reliability in the back end and so on, so you don't have to worry about it because the database takes care of all those worries.
My understanding is today the JDBC cache store doesn't participate in the InfiniSpan transaction.
It does not. So that's something we want to fix. So we want to fix it for one particular use case, which is for the shared cache store use case. Because doing it for the non-shared cache store means creating a very, very large distributed transaction, possibly involving many cache stores. It's something that we plan to fix by the end of the year, hopefully. Yes, that's one.
Okay.
Probably one of the most voted issues that we have?
Well, the reasoning for not putting it as super early, I mean, not already have it fixed, was that the data grid being already transactional has the right data already. Granted, there might be some kind of a problem downstream. So if you really want super synchronized, transactional thingy in the grid and downstream, then yes, that's where the feature is becoming useful. But if it's not necessarily the case, then you can rely on the reliability and transactionality of the data grid and have it non-transactional behind it. Who heard about our simple storage service from Amazon? Of course, you guys know about it. There is a super simple storage service, which is very useful when you need to store data, but never have to read it again. So what people do is, that's a classical approach on disk, and then what S4 does is literally a write-only service. So you can never read back your data, but they write extremely fast and extremely well, and it's very cheap. So if you have that use case, have a look at it. Sorry, it was a bit of a failing joke, apparently, but.
And one of the things about we get asked about in Finispan is how do I use it? So I think I've come up with quite a few different use cases. So the first thing that comes to mind is as a cache, as a local cache. So you read data from a slow data source, which can be a web service, a database, even computed data that needs to be computed.
Yeah, HTML fragments.
Yeah, expensive to compute, but once it's computed, it can be stored. It doesn't change very often, and it can be used. And in that case, you can have it local. You can have it shared between multiple nodes. You can decide not to transfer it by using invalidation. So there are different permutations of that pattern. Then again, the primary data source, we're seeing quite a lot of use of that. So since we have lots of interesting features, it's interesting to use those and not store the data somewhere else. So Finispan becomes the primary and not just your local data. And
by the way, I mentioned on that, some people use kind of a log-based system, like, I don't know, for example, the famous one is Apache Kafka, where they say, here is a stream of information coming in, and I will read that log of changes and push that information to Finispan and push that information to another data store. And that's because those two data stores will be used for different purposes. So that's also one way to, it's all primary in some shape, but you've got the redundancy and use the log as the kind of stuff that will allow you to apply the same logic and the same changes to all of your data stores, for example.
And then just as a clustering enabler,
yes.
You might not need to use Finispan by itself, but you want to you have an application, you want to make it clustered, and you just need someone to take care of managing the view of nodes and how those nodes interact with each other, and I think that's also a great example.
Who uses Wildfly? Okay, so that's the clustering technology. Or EAP, right?
Yeah, and then as a compute grid, so I know of people who don't use Finispan for storing data, but to manage distributed jobs. So again, you can do it with the data within Finispan, but you can also do it in more traditional jobs. For example, processing text files in a distributed fashion, and I've seen examples of that.
So you would store the text files in the grid first, or
on file system?
On the file system, locally to each node.
Yes, and then use distributed execution to.
Or to say read the local files and do whatever.
You don't even need to store them in the grid, but you can use that in Finispan to share state, for example, not the data, because maybe the data is far too big for the memory. So you huge big batches of text files, and you want the raw power of your hardware, but not the memory.
Cool.
I think that was quite an interesting approach there.
Do you guys have any remarks or question on the data grid in Finispan? caching. Cool. This one is it's before you store the data. Ideally, you want the data to be in a good shape. And Hibernate Validator, what it allows you, and the bin validation, which is the spec that is implemented by Hibernate Validator, is define in your domain model. So again, we're talking about the middleware taking some kind of ownership here about your data, where you've got your domain model and you express constraints on the domain model. This property called email should actually be in the shape of an email. So you can put an @email annotation on it. And this @email annotation is a trigger for Hibernate Validator to know that it needs to apply the email validator, which is, will verify that there is a, @ and it looks like a domain name at the end of it, and there is no space and whatnot, right? So we validate that it's an email. Of course, not null for a given property would work. A zip code, maybe if you're in, I don't know, in the US, the zip code has a very, very specific shape that you can validate, and so on and so on. And the cool stuff is that I'm describing very generic ones, but you can literally have your own business-specific constraints, and you express them via annotations, and you have a validator associated to it. And then you can use those constraints on your domain. So you declaratively express the constraints on the domain, and at the right time, Hibernate Validator will validate them. So what does that mean, at the right time? Well, the obvious one is when you literally call the validator and say, validate me this object or object graph, it will return you the list of constraint violations, and then you can do something with them. But the cool stuff is that it's not really the main use case for you to call this explicit API. The main use case is for other frameworks to call this API. So if you're in the Java EE land, JSF actually, before it actually go into one of those 120 million phase, has the validate phase, which just delegate to Hibernate Validator. Oh, you're about to store the data into this bin property. This bin property is marked as @email, so let's go and do the validation, right? So that's at the presentation layer. You can even imagine doing it on the client side by using a Hibernate Validator metadata API, and then have your client-side framework use those kind of constraints. It's also done by JPA, right, when you're about to persist an entity. If it's not a valid entity, maybe we shouldn't even put it in the database in the first place. And at every kind of boundary in the system, JAX-RS is another one. When you're coming in and calling a method with parameters, you can validate those parameters. If they are not valid, then we can raise I guess it's a 4xx kind of HTTP error code, or if the return value is invalid compared to what the user expects, it's a 5xx kind of error code.
So your data is always clean.
Cleaner than it was before, yes. It all depends, right? If you work with a legacy database, for example, you will use different level of constraints because let's say you want the user to give you good data. So when a new entry is created, you want the highest level of quality. But if it's an already existing data that has some kind of crap, you don't want the user to say, I'm sorry, I won't let you save this tiny little change until you fix all those problems, right? It's very annoying. So you can define groups in Hibernate Validator that says, this constraint belongs to this subgroup, and this constraint belongs to this subgroup. So you can define the high standard quality, medium, low level, whatever, to really do what you want.
Pedantic to relaxed.
Yeah, exactly, from pedantic to relaxed. Or pedantic 1 and pedantic 2, because you always know that two pedantic actually don't necessarily agree, right? Any question on that? Who uses it? Bin validation, Hibernate Validator. Okay. I encourage you to have a look at it. It looks very nice. By the way, I did talk about, yes?
The problem I use bin validation, I also not just when I use bin validation is, like, normally you'll get in a section say that something fair, right? Like positive bin validation. And I'm like, not only one portion of my bin to be validated, like all the bin to be validated, and to get like a composite of all the problems that happen, and not one exception when I try to commit to transaction or something. So is there any strategy for this?
Okay, so that's the kind of behavior you will get if JPA calls bin validation, because you're very, very down the stack and we don't really know where you come from. If the actual API of bin validation doesn't actually raise an exception. It gives you a list of a set of constraint violations that the caller actually do what it wants with. If the set size is null, then no problem, right? If the set size is non-null, then you can start doing things. What JSF or I guess Wicked, lots of web frameworks actually use bin validation. So what they do is they look at each of the constraint failures, and because there is a path from the root object being validated to the actual property or sub-properties being validated, they attach it back to the field corresponding. So the user has like maybe 5 errors, like, hey, your email looks weird, your phone number is, weird as well, and then you forgot to tell me your age, right? All of that in one screen, instead of saying, sorry, wrong email, and then the user fixes it and then comes back, oh, sorry, wrong date. So it really depends on the framework or how you literally use bin validation. So if you have an object and an object graph, you can cascade the validation so that when you validate this object, nested objects are also validated. You can do that with the @valid annotation in a Hibernate validator or bin validation. If you have several root objects, just call them one after the other, and then get this set of constraint violation and just compose them, and then you'll be able to go forward. So Hibernate ORM is, I guess, a venerable code base that has served us quite well. We're still trying to improve things. Recently, we've been rethinking the Bootstrap API, which was this big pile of, I don't know if you're familiar with the configuration API, and where you were like putting your properties and your class and whatnot, and you say, build me a search factory, and then you get things out of it. And because a lot of different conceptual phases were like mixed together, some of the improvements were really hard for us to go to, especially around the user types and the fact that they are somewhat static and you cannot pass specific information to them on a per session factory basis. So we did rethink the whole API, and the other big client is the modularization. So I don't know who uses OSGI or is forced to use OSGI. Okay, so we, sorry, I don't.
Nobody uses OSGI voluntarily.
No, I don't know. There are some people. Yeah. So it's my personal crusade, I don't know.
We're Philispine does OSGI, by the way.
Yes. And that's part of the reason that's my personal crusade, because we spend a lot of time.
The only thing that didn't work was the JPA cache store. And why is that? It's because Hibernate doesn't do it properly.
It's hard because we load a lot of different resources. The client class, we create proxies, which is very unusual for a simple library used by OSGI. We need to interact back with your classes, right? And that's doable in OSGI, but it's not necessarily super simple. By the way, I'm bashing OSGI here, but any modularity system has the same kind of problem. So we had to, initially we assumed that, hey, we can just take the thread local context class loader and everything will be fine. We just get the resource files, get the classes, everything works. That works in Java EE. It doesn't work in OSGI. It doesn't work in the modular Wildfly and so on. So we had to, every single time where we were using some kind of resource directly or indirectly, we had to rethink how to do it. So we've created a class loader service that lets, first of all, plug this kind of abstraction. So you can use the OSGI way to reach the data or the Wildfly way to reach the data. And then we had to work on the proper modularization of the, Hibernate already has different modules, right? Just like Maven modules. And then we had to make sure they could, work with one another. I think we made significant progress. There is, as far as I know, the problem is like having 2 Hibernate applications inside the same OSGI application is a bit of a mess. But if you have only one Hibernate application within your OSGI container, that should be OK. Don't quote me on that, because I'm not exactly really went into the details. We did work a lot around performance. There is a team that is working on EAP performance optimizations, and they found some interesting things we could improve on the object relational mapping side. So It's small details, but you will see the benefit. Every new version you're getting is better. And it's already started in the ORM 5 series. So just try and use the latest EAP, and you will get natural additional benefits out of it.
This also has the performance team has also been looking at the integration between ORM and second level cache.
Right.
And so there are going to be benefits there as well. Some things that we haven't been doing well are going to be greatly improved in the future.
I kind of forgot the detail, but there used to be something called Hibernate Spatial, which was a separated separated thing on top of Hibernate, and we have integrated it. So it uses the spatial capability of the relational database underneath. So Postgres has a very good geospatial API. Oracle has one, and whatnot. So you can store the actual spatial objects, whether they be points or more complex geometries, and store them in a native fashion to the underlying database. It's kind of a user type, but it's already bundled for you. And I'm not sure if we started working on the spatial query, the ability to express the spatial query in GPQL or not. I kind of forgot the detail here, but that's definitely in the plan. We're also exploring Java 8. Try and see if there are things we should do around it. It's a bit unclear we would benefit from lambdas, for example, due to the nature of JPA. Where we could benefit from lambda is to try and mimic what Microsoft has done with Link, which I didn't know, but they literally take a lambda, extract the AST out of that lambda, and somehow manage to convert that into a fragment of a query, say property A equals 12, and then that's how they create the query. So we could try and explore those kind of things. If you have questions, we're going to stay a few minutes after, and we can, talk to each other.